Okay, YouTube, in this video, we're going to go through just a strategy here for graphing rational functions. But essentially, when it comes to graphing these rational functions, I'll be real honest with you, what we're going to be looking for are the vertical and horizontal asymptotes. And then from there, just really piecing together the rest of the graph. So it's going to be important we can identify those values. So we say this strategy we're going to use for graphing functions of the form f of x equals a polynomial divided by another polynomial, where these have no common factors, which means it must already be simplified top and bottom. And we say that q of x is not allowed to be equal to 0. Here we say q of x. Let's make a little note here. Should not ever be equal to 0 because otherwise we'd have an undefined thing. So number one here says determine whether the graph has symmetry. And this is something that we tend to do by plugging in a negative x. And so if we were to start with this, we say f of negative x here would be 3 times negative x minus 3. And this would be all over negative x minus 2. So rewriting this, we get negative 3x minus 3. And this is all over negative x minus 2. And I notice that compared to the original function here, it's not exactly the same. And it's also not exactly the opposite. We'd say no symmetry on this graph. At least it's not even and it's not odd. So we know this graph has no symmetry. So this is kind of a superfluous step. We don't have to do this. But number 2 and number 3 we certainly want to do. So to find the y-intercept, okay, there is only one. We always plug in 0. So for our x, we say y-intercept. We'll go ahead and find this here. Our y-intercept would be f of 0. So in this case, since we have a polynomial on top and a polynomial on bottom, it's important to kind of do things separately. We have 3 times 0 minus 3, and we have 0 minus 2. So we'd get this on top, negative 3 over a negative 2 on bottom. We get really negative 1 point, or positive 1.5, pardon me, positive 1.5. And so I'm going to make a table of values here, and I think it'd probably be appropriate to put it over here on our graph, next to our graph at least. When we plugged in 0, we got this. We got 1.5. And I'm going to go ahead and put that on my graph right now. So we found our y-intercept. Let's go find our x-intercepts. Now, what do you remember about x-intercepts? We plug in 0 for x when we find the y-intercept. How do we find the x-intercepts? We plug in 0 for y. So x-intercepts, what we're going to do is we're going to set this whole thing equal to 0. And my favorite part about this is the only way a whole fraction equals 0 is if the top equals 0. So we say the x-intercepts. We're going to make a little note here. The x-intercepts are the solutions of our numerator polynomial. What this means is we can just go ahead and set the top equal to 0 and solve for what would cause this to be true. So we have 3x minus 3 equals 0. Adding the 3, we have 3x is 3, and so we determine x equals 1. This is an x-intercept of our graph, and we found it the same way we always do, which is set y equal to 0. Which in this case means we just have to set the top equal to 0. So we know it hits our x-axis at 1 right here. Dun, 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 dun. So here's what we found out about our graph so far. Symmetry, x-intercept, y-intercept, not necessarily in that order. So now, 3 and 4, these are essential steps. But we're going to do this for every rational function. We're going to start, sorry, not 3 and 4, but 4 and 5. Find the vertical and horizontal asymptotes. So starting with finding vertical asymptotes, it says do this by excuse me, solving the equation q of x equals 0. In other words, we're going to set denom equal to 0. You can write that in more detail than I have room here to write for, but we'd say, okay, so vertical asymptotes. These are always easy to find because we're going to set our denominator equal to 0. So we say if x minus 2 equals 0, then x equals 2 is one of our vertical asymptotes. So instantly, I'm going to go over to where x equals 2, and I'm going to put this on my grid. I'm going to say, okay, I've got my x and y intercepts. Now I have the one vertical asymptote that exists here. We're always going to label this. We say at x equals 2. So now I need to find my horizontal asymptote, if there is one, using the rule for determining horizontal asymptotes of a rational function. So remember, looking back at your original polynomial, we're comparing degrees. And what I learn here is this. When I compare the top degree to the bottom degree, it is balanced degrees. The top and the bottom of our ratio are kind of in balance with one another. So we'd say that our horizontal asymptote is the ratio of the leading coefficients, where our leading coefficients are 3 and 1. So we say y equals 3 over 1 or y equals 3. So here's our horizontal asymptote. And instantly, I want to go put this on the graph. So we say y equals 3. Okay. So with respect to what our graph looks like, I've looked at a few of these rational functions, but they tend to have branches. And as we get way far out on the left and the right, they get really close to the y equals number, or the horizontal asymptote is what I was looking to say. And as we get really close to this x value, where it's undefined, our graph is either going to decrease or increase without bound. So with respect to what we do next, it says number 6 here, it says plot at least one point between and beyond each x-intercept and vertical asymptote. So that means on our table here, because our vertical asymptote is at 2, I'm going to plug in 3 and 4. I'm also going to plug in 0 and 1, which I don't need to do 0 because I already did. And 1 was already done for us when we found that intercept there. It also says here, let's plug in at least 1 point and, beyond each x-intercept. I suppose 1 point beyond this x-intercept here would be 0 here. So we don't have to plug in -1. But we want to find out what does our graph look like in and around its asymptotes. Because I'll be real honest with you, out on the ends, this graph is very boring. It's just going to get really close to this horizontal asymptote. So plugging in these two values here, I want you to keep in mind that you're going to get a fraction on each answer first. So let's start with this. You want to take your time on these. We say f of 3 would be plug 3 into the top first. So 3 times 3 minus 3, which would be 6 minus 3, which is 3. So I get 3 on top. And on bottom, I get this. I say input minus 2, where we'd say 3 minus 2. So I get over 1. So we get 3 over 1, we get 3. So 3 comma 3 over 3 up 3 is on our graph here. And we would say that if we were to say now plug in 4, plug 4 into this, f of 4, we would say that in this case we would get 3 times 4 minus 3, not 2, 3. And this is all over 4 minus 2. So in this case we get 12 minus 3, which is 9, over 4 minus 2, which is 2, which we get 4.5. So here I get 9 over 2, which is equal to 4.5. So we're going to go investigate this here. We'd say 4 comma 1, 2, 3, 4 comma 1, 2, 3, 4 and a half. Okay, here. So let's investigate this here. I think that I have my point here wrong when I plugged in 3. If I plug in 3 on the top here, I get 9 minus 3, not 6 minus 3. So this would make this a 6. Okay, so I apologize for the late mistake in this video. This should be a 6 here. But I just felt like that couldn't be on the horizontal asymptote here. This would have to be up here. Okay, so now, number 7 essentially says this. Use the information obtained previously to graph the function between and beyond the vertical asymptotes. So in terms of what we've done, we checked for symmetry, kind of an extra step. Found our x and y intercepts if they existed. Then we found our horizontal and vertical asymptotes. So our x and y intercepts and our vertical asymptotes and horizontal asymptotes being on here. We just plugged in extra x values that were beyond the x-intercepts and the vertical asymptotes. So now that we have this, what we know is on the left, we have to go through these 2 points here, and we must start really close to the horizontal asymptote. And as we come into our undefined x value from the left here, we're going to get something that decreases without bounds. So our left branch looks like this, and our right branch would look like this. So one thing we were not asked to do on this one that I do want to do is identify the domain and range. So the domain here would be negative infinity up to 2 in union with 2 to infinity. All x values except for the one that we excluded on our vertical asymptote. And it looks like the range of this graph would go from negative infinity all the way up to our y, or our horizontal asymptote here, 3, that y value, in union with 3 to infinity. So we're going to use this process again in the next problem here to graph another rational function. Cheers.